Okay. So, shall we start now? Boleh? Boleh dengar tak?
Boleh.
Boleh.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh. And selamat pagi, very good morning. Well, we are waiting for another 6 or 7 students. There are in total 47, is it? Yeah, 47 in my students list. Okay, I'm Anim Osman. Just joining back UTM last week. And now I continue for the topics 7, plain trust. Plain trust. We have 2 hours lecture today. But every 30 minutes, I'll give you maybe 5 minutes breaks or give you chance to ask any question. If it is possible. But I'm not very familiar with this online. I hope there's no problem. Okay. At the end of this lecture, actually I have one tutorial. If I couldn't upload the tutorial, I send to everybody of you through WhatsApp PDF file. Then you can print and you can submit later on. And also, as far as I know, I'm informed that the this lecture for this session, this semester, will end on 31st January. Is it correct? So that means we have only another 3 weeks from now. And early February we will have celebrate Chinese New Year. And the final exam will be at mid of February until end of February. Okay, because I don't have UTM calendar with me at the moment. But this is as far as I'm informed by the office. Okay. Are you ready now? Okay. Oh yes. Are you all local students? Or I informed that there is one international student, but I'm not sure. Who you are? From this list, it is not clear. Whether it is from Africa or from Arab or from Indonesia, I don't know. If you know the name or you understand, you yourself tell me who is the international student. Please let me so. Okay, plain trust. Before I continue with this lecture, I hope you still remember what you have learned in your first year, in mechanic or engineering mechanic, because for this lecture or for all the topics, actually the basic is has been already taught in first year static, where we learn about the equilibrium of forces, force and also stress in the last week or last 2 weeks. So if you are not familiar with the equilibrium of forces, I hope you can do homework, so that it is easy for you to understand the lecture note and also to do the tutorial. Okay. And I also hope that you have one copy of lecture note given by Dr. Yunus already. Because without the lecture note, I'm afraid that this lecture will not be efficient. Okay, there are some slides that's not contained in your lecture note. Some additional slides, some additional figures, some additional photograph. Okay, for example, this slide is an additional slide. Types of structure frame. I think you have learned this type of structure frame in first year, introduction of structure engineering. Beam, grillage, plane truss, space truss, plane frame, space frame. So I don't have to give the photograph or figure. This is just an revision. Structure frames mean sometimes we call it skeletal. Skeletal frames or skeletal structure. This is different from like membrane or like solid structure. Where you have continuing material. But this one is based on basically made of bar. Bar or structure frame. Okay. Okay, and this is our topic, truss structure. As it is shown in your slide notes, we will consider these two type of structure: roof truss and bridge truss. Roof truss and bridge truss. If you see here, this is roof truss. This is a very large span roof truss. And you see, it is only made of a very small member. You call it frame member or skeletal member or bar member, which are arranged in such a way that it will able to carry load from the roof, from the imposed load. Will come to little later. And this is bridge. This bridge. So a bridge, it is made of a bigger structure, a bigger member, because the loading is much more higher than this roof truss. For a bridge, loading is from what? From traffic loading, lorry, bus, and but for truss, the loading is only from roof tile and also from the service conduit. Okay. What is truss? Okay. A truss is a structure of slender member joined at the end of points by pin, bolting, or welding. But my comment here is that majorly, if you check the definition in the textbook, truss is associated with pin connection. Ideally it is pin connection. If it is bolting or welding, it depends actually on the size of bolting and welding in relevant to the structure. If welding is small, in relation to the structure called, then it is considered as pin connection. And this about the connection we also have learned in first year, pin connection, fixed connection, rigid connection. The truss consists of whether wooden truss, polymer structure, metal bar, steel bar, or cold form bar, or aluminum bar, or okay. This is what we call it pin connection. Pin connection, where it is connected by only very small connection in relation to the member itself. This is called ball joint. Ball joint. So if you say this connection, it does not carry moment and also shear force, only axial force, and this is most textbooks or definition, this is the definition of trust, where the member is subjected on yeah. That's why I add one here. Conventionally, some members are subjected to axial force only. If it is subjected to axial bending moment and shear force, yeah, normally be frame. Yeah. Okay. This is truss. Yeah. Pin connection. This is also pin connection. This one is three dimension, yeah, where we can use as a space. The next topic, space truss, and this is. And what is this? This one is a gusset plate. Yeah. Gusset plate. So whether it is pin connection or rigid connection, it depends on the size of this gusset plate, whether it is small or the whole size of gusset plate. And this one, this is welded connection. So welded connection, it is connection. The member forces axial motion, spin or rigid also depend on experimental tests in the lab. Okay. So what is the objective of this lecture? Yeah, to determine the stability and determinacy of the plane truss. Yeah, which is at the very beginning of the working example, to analyze and calculate the force in the truss member. Okay, this is the major part of the topic, and the final position at any joint. Okay. So what is roof truss? So not much different between roof truss and bridge truss. The difference is only that the bridge truss is bigger than roof truss. Yeah. Okay. Roof truss transmits loading from roof to column by means of series of purlins. Okay, this is roof truss, and this is loading. Where the loading come from? Yeah, the loading come from servicing, also from the imposed load from worker or from snow load. Yeah, and called purlin. So this is tile is concrete tile. Yeah, is heavier than asbestos, heavier than or metal decking. Tile purlin, and then purlin transfer the tile the loading to the roof member. Yeah. Here we call it rafter. Yeah, this is rafter. This is called bracing member. Yeah, this is rafter. Top rafter and bottom rafter. Okay. Trusses use support roofs as selected on the basis of span, slope, and roof material. On whether this is concrete tile or asbestos. Yeah, because different material, different density, different loading. So yeah, it will influence or determine what type of material, what size of truss member. Okay, this is just to show different type of truss. Yeah, you can check from the manufacturer's detail or from the internet. Yeah, whatever the name, having double hole girder, yeah, or fan bobtail, flat top. The name is not important. Important is how to calculate or how to analyze the process. Yeah, another type. Another name. Low profile raised iron. Yeah, Yeah. Some more type of trust. You can choose any type, and you can choose any trust. You can also choose which trust is more suitable for if maybe more economic, maybe more information. Yeah. Okay. There are many type of trust. And which trust. Yeah. So the difference is that yeah, the member are bigger and the connection are normally big connection. Yeah. Job doesn't play. Yes, big trust. Yeah. Okay. Uh, if we check from the uh, uh, literature, yeah, there is another frame. Yeah, that you see here. It is made of rectangular. Rectangular. Rectangular module. So this is actually by definition it is not a truss. It is called frame. Yeah. But some definition considered as a truss also. The difference here is that for this what we call Virendial truss. Yeah. Here the member is subjected to not only the axial force but also the axial force, bending moment, and shear force. So this is called frame. Yeah? But some definition considered also as truss. And we call it Virendial. Yeah? Axial, shear force, and bending moment. So it is not included in our scope of lecture. Okay. Just now about what we have done in our first year post reduction and resolution because in all the method of calculation for the trust to utilize, you need to understand, we need to familiar with this resultant and resolution. Okay, so this is force. F is so this force, it has component, component in x and component in y. Fx and Fy. This is F1. Due to Fx and Fy, this is the formula. Just based on trigonometry. Theorem Pythagoras. Square root of Fx squared plus Fy squared equal to F. So I think it's three formulas that will be utilized. Will be very useful in all the calculation. Assumption before, because analysis or in any engineering analysis, we have to do assumption. What is the ideal assumption or ideal condition of the structure or the building or the frame? Because when actual condition in construction, the condition of joint, the joint you see in the textbook. So we have to idealize the actual condition before we do assumption. The members are joined together by smooth spin, no friction. So this now. Yeah. A joint can be considered as spin, although it's not appeared as if the size of the member of the structure. Okay? And no friction means it's free. Yeah, free movement. Yeah, no friction. Yeah, I can show you no friction here. Okay, there's no friction here. There's no friction here. Yeah, so we call it as spin ideally. And all loading and reaction are applied at the joint. Yeah, not at the eccentric of the joint. Sorry, I have to go back here. Joint. So this joint must be installed or must be fabricated. Yeah, very a good condition accurately so that the force will go through the joint centroid. Similar in all conditions. Yeah. So this is the second ideal condition assumption. And the centroid of each member are straight and concurrent at the joint. Sorry, we have to go back again. It is the centroid. For example, this one. Okay. We can see how many there are 12 bolt. 12 bolt. What is the centroid of this bolt? Yeah. So this centroid of this bolt, the centroid of this bolt, okay, here should be collinear with its member. This orientation, the worker should fabricate or fix and the bolt very accurately, symmetrically, so the center is in line with this. This is the assumption. So that because of this three assumption, x force, the force to elongate or tensile, we call it tensile. Sorry, to elongate we call it tensile, and it is because of compressive. Yeah, we have learned about this in static. This is the convention, the sign convention for the tensile and compressive. Yeah, where it is tend to what elongate, tend to elongate. So here the external force is going outward. From this member here. So member yeah, reaction. So R is equal to 3. M is member. How many member? Yeah, 1, 2, 3, 4, 5. So it comes into the example later on. Okay, so this is the formula. And for every joint, two equilibrium can be written fx0, fy0. Because every joint, you have two equation. That's why here you have 2j, two equation. for each joint. And then by comparing M plus R and J, and 2J, then we can determine whether it is determinate or indeterminate, or whether it has redundancy or otherwise unredundancy. Okay. Okay, we'll come to the example later on. Okay. But for the external redundancy, it is simple, easy. Just to check whether R equals 3 or not. What is in external internal determinacy? External means reaction. Internal means member forces. Okay. For the external determinacy, if reaction greater than 3, then we call it statically indeterminate. If it is 3, statically determinate, and if it is less than 3, then it is unstable. Yeah. Okay. What happens if it is less than 3? Yeah. If it is less than 3, yeah. So what happens is that, yeah. For example, one here, and this is roller. Yeah. And if it is roller, so you will have 2 only. So when you have only 2, that means this structure can move. Yeah, can move left and right. So it is not called structure because it is not stable. Yeah. Maybe it is not collapse. Yeah, but it is not stable. It can displace. Yeah, displacement. Okay. Uh, okay. For the internal determinacy, yeah, it is for member. M equal to 2J minus 3. Okay. And this is the formula. Yeah. I will go to example later on. Uh, where which which the case where M greater than 2J minus 3. We go to the example. Okay. Example 1. Determine the stability and determinacy of the thrust. Okay. This is pin connection. This is roller connection. For pin connection, there are 2, and for the roller connection, only 1. So total external reaction 3. Okay, 3. R minus 3 equal to 3. Therefore, R minus 3 equal to 0. Therefore, it is externally determinate. Okay. And what's about the internally? Yeah. How many member? Member equal to 9. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. And join 1, 2, 3, 4, 5, 6, 6. So, using this formula, M equal to 2J minus 3 equal to 0. Then it is externally and internally determinate. Or we can say that there is no redundancy. No redundancy. Whether internally or externally. We have another example here. Example 2. How many reaction? 1, 2, 3. Okay, for this case, this is roller. Even though it is slanting, not horizontal or not vertical. As we have learned in first year in friction. For the friction for the roller, the reaction should be normal to the surface. Then we only have one reaction. And actually this reaction is a resultant of horizontal and vertical. But the resultant of this horizontal and vertical component is always normal to the sliding surface. That's why we have only 3. And 3 minus 3 equal to 0. That means it externally determinate. And internally also, m equals to 9 and so on, then it is also determinate, so that we call it externally and internally determinate. Okay, and what's about this structure? It's about the same structure, but what the difference here is that you have one additional member here. So when you have one additional member here, m equal to 10, but j is still 6. So now we have one redundant member. This is called redundant member. So we call it internally indeterminate. 1 degree of redundancy. And when it is internally indeterminate, we cannot solve the problem here. We have to solve the problem next year. Using virtual method or using computer application. You will continue to learn this structure analysis in third year and also in fourth year. And finally, you will use computer to solve the very complicated structure in many more cases. And externally, you have 4 reaction here because it is one is spin, this one is spin. So 4 reaction. So very simple. If 4 reaction, that means 1 degree. 1 degree redundancy. So that means in this case, the stress is has 1 degree of redundancy externally and internally. And we cannot solve this problem here. So wait, next year. Okay. Okay. Now, we start to go for the analysis. So as I promised, before we start, I give you 5 minutes breaks. And maybe because I'm not familiar with this online. Maybe if you can, you can try to ask if any question, whether I can hear you or not, and also actually for the attendant, I have attendant this year 47, I pin here, but I think I have to check, from the attendance sheet, from the participant. Okay, how many of you now? 42, 42. We have 47 here. I don't know what Dr. Yunus normally check attendance. I have your name here. Okay. Based on your name, I check the attendance now. So I give you 5 minutes breaks. Another 3 minutes. I'll check the attendance. Okay. Okay, start from in my list here, Nazura. Oh, this is quite difficult for me to check your name, because your nickname here does not start with your first name. Okay. Olivia. if you use the same name as your attendant, it is easier to me. Okay, can you voice your name? Is it okay? Nazura. What's your first name?
Nur Amirah.
Yeah?
Nur Amirah.
Nur
Nur Amirah.
Nur Amirah. Nur Amirah Nazura. You boleh tukar nama kepada Nur Amirah kan?
Boleh.
Mungkin next time senang sikit. Nur Alia. Okay, Nur Alia, okay. Okay. C. Chinese senang Syafika. Wan Nur Syafika. Syafiq Iqmal. I don't know what's your first name. Syafiq Iqmal.
Muhammad, Dr. Muhammad Syafiq Iqmal.
Sebab kalau kita nak cepat, kita kena guna first name.
Saya Nur Syafika, Doktor.
Syafika ada. Syafika saya dah dapat. Syafika.
Nur Syafika.
Wan Nur Syafika.
Bukan. Nur. N-O-O-R.
Nur Syafika. Okay.
Wan Syafika pun ada, Doktor.
Ya?
Wan Nur Syafika pun ada.
Ada.
Nur Syafika ada.
Oh, kenapa? You kat asrama ke?
Tak ada dah. Tempat lain.
Oh. Wan Syafika ada. Wong Shimi ada. Yung ada. You bila balik asrama? Belum lagi? Okay.
Next sem kot, Doktor.
Next sem? Okay. Alik Hilmi. What is your first name, Alik Hilmi? Saya tak jumpa. Afikah Yunus. Oh, nombor 1. Aina Akila. Nombor 2. Aisyah. Nombor 3. Amir Afwan. Okey. Terus An-Nur. Okey, kalau ikut ni senang. Andi. Okey. Ang. Okey, Anis. Atira.
Depan Nur, Doktor.
Ya?
Depan Nur, Doktor. Nur Atira.
Nur Atira. Oh, 39. Okey. Atira tadi apa tadi? Atira. Andi. Amir Afwan, An-Nur, Andi, Anggia Chang. Okey. Chan. Alice Ling. Iva. Farah. Haris. Haziq Hakimi. Haziq and Haziq Hakimi. Haziq Suhaimi, Haziq Hakimi. Haris Hakimi. Haris Haikal. Haziq Hakimi. Tak jumpa lagi. Kabinesh. Okay. Koh. Okay. Kong. Okay. Nabil. Nabil Ramadan. Tak jumpa.
Muhammad.
Muhammad Ad-Din. Muhammad Nabil
Muhammad Nabi.
Muhammad Nabil Ramadan, okay. Muhammad Faisal. Muhammad Ad-Din. Muhammad Adib. Muhammad Afiq. Muhammad Najmi. Muhammad Ibrahim. Okay.
Yes, doctor.
Lai Yanjun. Okay. Ling. Okay. Maz. Okay. Muhammad Najib. Najib Afifi
Muhammad Najib dia.
Muhammad Nuruddin. Muhammad Nuruddin ada. Okay. Hizwin binti Muhammad Fuad ada tak? Hizwin.
Tak ada.
Tak ada. Okay. Nazurah. Nazurah ada? Ada. Nur Alia sudah.
Ada.
Okay. Cuba yang saya belum dapat ni confirmkan ya. Muhammad Afiq Hilmi. Tak ada. Nadrah binti Mustafar.
Ada doktor.
Ada.
Ya.
Okay. Siti Syakirah Muhammad Faizal. Syukrina Fikriyah. Okay, tak ada. Taufik Hamdi. Okay. Nur Nadiah Khadijah binti Mahzir. Belum ada lagi. Amirul Aiman tak ada. Faris Razi tak ada. Okay, nanti saya akan panggil lagi sekali nanti ya. End of this ni. Ada 43, dia ada 47, mana ada 4 tak ada lah. Okay, ya, kalau tak ada apa-apa kita sambung. Tadi siapa yang international, siapa namanya? Siapa tahu? International student. Siapa nama?
Muhammad Ibrahim.
Oh, Muhammad Ibrahim. Muhammad Taufik Bondok. Is it? Betul ya? Muhammad Ibrahim ya? Where you come from, Muhammad Ibrahim? Yeah?
Yes, doctor.
Where you come from, Muhammad Ibrahim?
I'm from Egypt.
From Egypt. Oh, okay. Okay, we continue. Yeah. Okay. If you have a question, you can write WhatsApp to me later on. No problem. We can share. Okay. Okay. You can also email. Okay. Okay. Member forces, yeah. We have another 1 hour. Okay. There are 3 methods, yeah, to calculate member forces of truss. Method of joint, yeah. You have also learned in first year method of joint. for the simple, yeah, for the two member or for the cable, yeah, simple. So it is based on equilibrium equation of at joint, where you have two equation, two simultaneous equation, fx equal to 0, fy equal to 0. You remember? So this is method of joint. So in your first year, you have another one joint, yeah. But in this, yeah, trust, yeah, problem, we may have, yeah, maybe, yeah, 3 joint or maybe 20 joint, yeah. So you move from one joint to another joint, yeah. At any joint, you just use the simultaneous equation fx equal to 0, summation fy equal to 0. That's it, yeah. And yeah, as I mentioned, yeah, just now, we must familiar with the fx and fy, yeah. Fx equal to f cos angle, fy equal to f sine, yeah, yes, sine angle, yeah. Okay, method of section. This is method of section. Method of section, yeah. If you need to know only, for example here, you need only to know the middle section or the middle member. So we just cut here section, and then we can calculate what are the force in these three member. So this is useful when you have very long truss. Yeah, for example, you have long truss, yeah, where maybe there are 50 member or maybe 50, 100 joint. Yeah, yeah. But you may only to know, yeah, the member with maximum force in the middle of the truss. So we just cut here, and then, yeah, you can calculate, yeah, or you can determine, yeah, the member forces, yeah, for that extreme or largest value. Okay, yeah. And method of force resolution. Okay, what is the difference here? For this method of resolution, yeah, you not only to know the joint equilibrium but the member equilibrium. Okay, member the member equilibrium in here is a solution and resolution. For example, here, okay, you have one member, one force here. In this case, is reaction force. So this reaction force, you must apply. Okay, this member should oppose this force, yeah, in such a way that the component X and component Y, when it is combined, it will collinear into this member. Okay, in this case, yeah, this force should equal to this force because there is no more other force. Okay, and this force, the value of this force is in such a way that the combination of these two will collinear with this direction. And we'll come into the example. Okay. This is called method of force resolution. Okay, so this is joint, yeah. This is method of joint, method of joint. Okay, we just use the equilibrium of fx0 and fy0 for each joint, and we move from one joint to another joint. That's the basic method, yeah, the basic principle of this joint method, yeah. We just use the free body diagram, limiting the unknown values to 2 only. Free body diagram here means free body diagram of this joint, not the structure of this joint. And the selected joints must only consistent concurrent and coplanar forces. Yeah, concurrent and coplanar forces means here. Yeah, okay. For example, yeah, this is joint method. Determine all the member forces for the given thrust. Okay, this is the question. Yeah, the typical question in tutorial and also in examination. Okay, first, what we should check here is the stability and determinacy of this thrust. If the thrust is not stable, that means the question is not correct. If the thrust is not stable, the question is not correct. Okay, because if you check one of the definition in the textbook, the structure is not called structure if it is not stable. Okay. To check the stability, it is easy. To check the stability, as long as there are three, not less than three, then it is stable. Okay, and if it is more than three, then it is indeterminate. Externally, not internally. Externally. Okay, so in this case, how many? 1, 2, 3. So it is externally determinate. And also it is stable. But what about if it is 4? If there are 4 forces here, external force, is it stable or not? This is more than stable. This is more than stable. And if you have 5 or 6 reaction, it is too stable, very stable. But it doesn't mean that it is indeterminate. It is determinate. Okay. And then internally, how many member? How many join? 11 member, 7 join, and then minus the minus 3. 3 because there are three reaction for the equilibrium, for the stability. Then it is equal to 0, then it is okay. M minus 2j equals 0, then it is okay. That means it is externally and internally determinate. If it is indeterminate, whether externally or internally, so it is very difficult for us to continue. So check that it is determinate. Okay. The first step is reaction at support, because before you start with the calculation of member forces, you must calculate the reaction. Otherwise, you cannot proceed. So the first step is to calculate the reaction at the support. So the basic method, the principle here is there are 3 equations. Equation 1, 2, 3. Equation 1 is for moment equation, and equation 2, 3 is for force. For this, for the moment, for reaction and support, we consider the whole structure as one rigid body. The whole structure as one rigid body. Okay. I think I'm not going to go into detail for each one. Maybe for this first example, it's okay. MA equal to 0. Why A? Okay. You can also use G. You can also use A. You can also use B. You can C, D, E, F. You can also use any point here, anyway, for the moment equation. But choose the simple one. The simplest one here is whether A or G. Because when you consider the equilibrium of joint A, that means here that you can straight away calculate the reaction at G. That's why you choose A. If you choose G, okay, you have 2. Then you cannot solve the equation. So you start with the A. Okay. And then once you know RG, then you have another 2 reaction left. horizontal and vertical reaction at A. Then again, you use free body diagram, but in this case is the equilibrium equation for force. Yeah, this one for moment, this one is for force. Yeah. So remember, three equation: equation 1, equation 2, and equation 3. Okay. Yeah. Y. Yeah. Sorry. Fy equal to 0. Ra minus 50. Yeah. Minus because it is downward. Downward. 50 downward minus 167 here. 167. Yeah. Why it is minus? Yeah. Why it is? Sorry. Yeah. 167. 167. Fy equal to 0. Ra minus 150. Oh, okay. This one should be downward. This one should be downward. No. This one correct. This one correct. This one upward. But this one, why it is negative? It should be positive. This one, it should be positive here. Because it is upward. You check. I'll check later on. You check here. And HA, we use Fx equal to 0, summation force in x direction equal to 0, 100 plus minus this one. So this one 100 in opposite direction with the applied load. Okay. And now we start to analyze every joint. Once you know the reactions at the support, then you can start to analyze every joint. You start with what? You start with the simple one. The simple joint. We must start with the simple joint. We cannot. Don't start from joint D. Don't start from joint C. Because if you start from joint C, there is no external load, and you only have there are 3 members. You must start with the joint with 2 members. Remember? You must start with joint with 2 members only, because in joint method we have only 2 equations. X and Y direction. 2 equations. If the joint connecting 3 members, that means there are 3 unknown, whereas you have only 2. So you cannot solve the equation. So you must start with the joint with 2 members. So in this case is A. Whether A or you can start G. Okay, you can start G. Okay, if you start A, so 32.1 is the reaction. We have calculate determine in the last slide. 100, and then very simple. Fx equal to 0 minus 100 plus Fd equal to 0. This one equal to 100. This one equal to 32.1. Very simple. That's right. The point from which we start, we must clever to start from when. Okay, and then from joint A, you move to joint B. Okay, why you move to joint B, not joint D? Because in joint B you have 3 members unknown. When this member is known already, then you have only 2 left. Then, as I said before, just now, the joint must have member not more than 2. Okay, so that's why we go to D, not D. Okay, if you go to D, we know the force in this AD member, but there are another what? 1, 2, 3, 4 members. So it is impossible. Okay. So similarly, I don't have to go into each of this equation. using fx0 and fy0, fy0 and fx0, yeah. Okay. So this is component, yeah. 6/10 is the y component, or we can use FBD sign, angle between this, yeah, between axis x or y or to this member. But here we don't have we don't use the sine and cosine, yeah, but we use this one. 6/10. What is 6/10? Okay, 6/10 is actually, yeah, 6/10. This one 10. Eh? Why it is 10? Because it is theorem Pythagoras. Eh? This one 10. 6/10 is the sine. Yeah. Sorry, 6/10. 6. Sorry, 6. 6/10 is equal to the sine of this angle. So this is what, yeah, we mentioned, yeah, just now, the component or rectangular component of force. So we must very familiar, yeah, with this one, whether 6/10 or whether 8/10, and this one 8/10. Okay. So this is your job, yeah, to make it familiar with to you, yeah, about the sine and cosine, or about the rectangular component in x and y direction of each member. So this is the answer, yeah, and I think, yeah, we move, yeah, to join C, yeah. Now after you, yeah, after we know the BC, yeah, we know BC, yeah, then we go to join C, because in join C, yeah, there are 3. If we know this BC, then there are only 2. If you have 2 members, then we can solve the problem, yeah, for that join. Can you go to join D? Okay, now you know BD, you know AD. Okay, if you go to join D, you have how many? 1, 2, 3 unknown. Then it cannot solve the equation solution, because we only have 2 simultaneous equation. Yeah, so that we go to C. Okay. Then when we go to C, yeah, we will have another 2 member, yeah, determine CE and CD. And now, yeah, when you know CD, then 1, 2, 3, yeah, we know this force, then we can go to D. Can we go to E? Cannot, yeah, because, yeah, there are 4. If you know only 1, that one another 3, yeah, that means another 3 unknown. So we cannot go to E, you must go to D. I hope you understand, because during the examination or during the test, we must, yeah, do a very quick decision, where to go, yeah, to go to E or to D. If you go to E, yeah, then you lost, yeah, then you have to go to D. Yeah? Okay, yeah, okay, now you go to join D, yeah, then, yeah, you can determine, yeah, DE and DF, yeah, and then now you can go to E or you can go to F, yeah, any join, yeah, you go to E or you go to F, yeah. Okay, when you go to F, you know this, sorry, yes, okay, sorry, oh, you have load here 50, yeah, 50. Yeah. Okay. 50. Yeah. 50. So yeah. Very simple. Yeah. When this one is 50, it must be also 50. Yeah. It should be 50. Yeah. 48.9 because yeah, it comes from here. Yeah. 49.8. Sorry. But actually, yeah, it should be equal to 50. Yeah, because you have a decimal point here. Error. Okay. For this join F, it is very simple. Yeah, because there is no component, yeah, other from X and Y. Yeah, vertical and vertical component. So it's very simple. Yeah. So there is no sine or cosine. Yeah. So FFG should be equal to 160.7 and yeah, EF should be equal to 50. Okay. Now, so far, yeah, we have gone through all the members. Yeah. Now, do we need to go to join G? So now join G we use as a check, double check. Yeah, we go to join G. If join G is equilibrium, yeah, in X and Y direction, then it is okay. If it is not in equilibrium, that means there must be something wrong in your previous calculation. Then you have to check again from the beginning. Okay. So that means it is very important for us to check the joint G. Yeah. Okay. That's one example. Yeah. We have another 40 minutes. Yeah. Okay. Another example. Oh, sorry. Okay. This is the summary. I think I should explain something here. It is not in the slide. In your slide, you have this one, list of member forces. Yeah, some are negative, some are positive. Negative is compression, positive is tension. Okay. And alternatively, actually, you can also showing the summary of the forces, yeah, on this figure. Yeah. Okay. And this is, yeah, maybe it is more clear. Yeah. If you represent in this figure, okay, 32.1, take for example 32.1 for member AB. Yeah, this is the direction of the arrow. Yeah, direction of the arrow for compression. Yeah, for compression. Yeah, the direction of the arrow is, yeah, going out from the member. Going out from the member. Yeah, or you can imagine. Yeah, you can imagine if you are here, what you are feeling. You feel to what? Yeah, push outward. So that's why the arrow, yeah, the arrow hit is, yeah, push out. Yeah, because it is in compression. Yeah, or you can put negative here, or if you have arrow here, you don't have to put negative because this arrow already, yeah, recognize or, yeah, really show that this one is in compression. And what about this one? I just give two example only. 53.5. 53 here. BD. BD is positive 53.5. Positive is positive means tension. So this is the arrow. The arrow is what? Come inward. Yeah, come inward. So yeah, inward. You tarik. Yeah, pull inward. So this is in tension. So do we need to write positive here? No. Yeah, if you write positive, okay, yeah, but no need because this arrow, yeah, this arrow already show that, yeah, already show that this one is in tension. Okay, I hope you understand it. Yeah, and it is actually very much, yeah, beneficial if you can, yeah, summarize or show the force together with the arrowhead on the structure itself. More practical. Yeah. This one is practical if you use computerized, yeah, because in computer, when you do programming, you the program read one by one, whether it's negative or positive. The program, it does not recognize this arrow. The program, only recognize positive and negative. That's why, we use table here. Okay. Oh, method of join. Method of section, method of section. Okay. You already read this note, is it? I hope so. Cutting to two parts, provided that the unknown values are not more than 3. The unknown values are not more than 3. What does it mean? Here. If you cut here and the cutting is through 3 member, then we can solve the problem. If it is more than true, if it is more than it is more than 3, then we cannot solve the problem. So you must cut through 3 members. What happens if there are 4 members? So you have to do 2 steps. Step 1, cutting to 3 members, and another step, cutting to another member. And what are the equations? In joint method, we use only 2 equations, fx0, fy0. But in section method, we use free body diagram, rigid body diagram here, fx0, fy0, and m equal to 0. Similar to what we have done in determining, calculating the external force reaction. The whole diagram. But in this case, we cut into 2. For example, here. Determine the member forces for BD, DE, and CE. Okay. And notes again. We have no time to explain this. When this is 1 and 2, what is the angle? What is the component X and Y? When we can use fx equal to f sine alpha or f cos alpha. I hope you take it as a homework to you to study at home, to familiar with this rectangular component of force. Okay. So now BD, DE, and CE. BD, DE, and CE. Okay. Yes. BD, DE, and CE. So how to cut this truss to determine the force in the 3 member? Can we cut the truss here? Sorry. Can we cut the truss here? Cannot. Sorry, it's not enough. Because if you cut the truss here, what you can calculate is BD, CD, and CE. Okay. So what we can do is we need another cutting. We need another step. Cutting another one. Cut another one. Cut another one. Cut to 3 member. Not 2 member, 3 member. because we have three equation. Yeah, three equation. So when you have three equation, yeah, you have to cut to three unknown. Yeah, three unknown or three member. So this one three, this one also three. So from this section cutting, yeah, you can know what you can calculate the force in BD, yeah, in BD, CD, CE. Then you can calculate another two member. Okay. Okay. Now, similarly, yeah, we start, yeah, from reaction at support. Yeah, I think, yeah, I don't have to go into detail here. Yeah, you have to understand how to calculate the reaction at support. And if you don't understand, you can, yeah, just ask me, yeah, whether by WhatsApp or email, or maybe you can sketch, yeah, what you don't understand. You can sketch on paper and then take photograph and then show to me. Yeah, or it's better if you can, yeah, come to UTM, and we can have a tutorial session. Yeah, that's better actually. Yeah. Okay. I heard last week. I heard that students from foreign students, yeah, start to come to UTM. So I don't know why. Yeah, why you can come to the hostel. Okay. Yes. This is first. This is first section or first cutting. Yeah. This is first cutting. First cutting. The second cutting will be here. This is first cutting. The second cutting will be here. Okay. So first cutting. So why we cut here? Yeah, I have explained just now. Yeah, to cut through a section where there are not more than three members. Yeah, there are not more than three members. If there are four members, cannot, because we only have 1, 2, 3 equation. More than three, cannot. Okay. So this equation is for the rigid body diagram. Rigid body diagram, when you have equilibrium in X, Y, and also in rotation. Yeah, in rotation. In free rigid body diagram. When you said free body diagram, maybe it applies to joint and also to the whole structure. Okay. So MD0, why again? Why you choose D? Why not you choose E? Because if you choose D, this force, yeah, this force, it goes towards D. That means, yeah, from this equation, yeah, sorry, from this first equation, from rotation equation, you can straight away determine what is FEC here. Once you know FEC, yeah, then it is easier for you, yeah, to calculate FBD and FDC from this second equation. Yeah, similar to, yeah, in reaction, you can choose any point. You can choose E, you can choose D, you can choose E, F, you can choose here. Yeah, you can see the cursor here, or you can choose here. Yeah, anyway, yeah, whenever you choose, yeah, the point, you can solve the equation. But of course, yeah, you must know how to choose the most easiest way. Yeah. So the most easiest way here is to choose D. Okay. Okay. So you see here, yeah, from only one calculation, from only one step of calculation, you can solve the problem or solve the question. Yeah. Sorry, I mean solve the Disney member forces here. And yeah, because the question is, yeah, also include this force, yeah, then you have cut another one. Yeah, you have to cut another one here. And remember what is the rule here? When you cut, there should be 3 members. Yeah, there should be 3 members. Not more than 3. 2 may be okay, yeah, but not more than 3. So you see here, we have 3 equations, but because we already know the force in another 2 members, then we have only one equation left. That means that is the rotation equation. Okay, yeah, because we already know what is FEC. FEC. Yeah, and then the question is on FED. The question does not ask FFD. Yeah, only FED. Okay, so yeah, sorry, FED. Yeah. Location is on FED, not FFD. So we have to choose a point where FFD, yeah, FFD is cancelled out. So we have to choose F. If you choose E, what happens? If you choose E, okay, this unknown, yeah, this unknown may be cancelled, but what you got from rotation about E is FFD, whereas FFD is not the question. So you choose point F. Understand? You can choose E. Yeah, no problem. Yeah, but you will have to construct 3 equations. If you choose F, only 1 equation. Okay, so it's very important, because in the examination or in a test, time is limited. Yeah, so we must choose the point or the joint where it need less equation, minimum number of equation. Okay, so yeah, we have solved the problem. Yeah, second method. Yeah, we have another one method. Method of force resolution. Okay. Any questions so far? No question? Yeah. I hope you have read the lecture note, yeah, before you come into this session, because otherwise, yeah, if this is the first time, yeah, you see this lecture, this notes, it's quite difficult to understand. Yeah. Method of force resolution. This is an extended version from the method of joint, yeah, where you use the concept of equilibrium of joint and members. And in this method, we work, yeah, we do the work on the figure itself or on the structure itself. There is no equation. Yeah, sorry. We don't have to write the equation. Equation 1, 2, 3. No. Yeah. Good here. Okay. Example here. Yeah, this example. This is a very basic example. Not included in your lecture note. Okay, this is very basic example. Yeah. Also, you have learned also in first year. For example here, 10, 40, 1.5, 2 meter. Okay, what is the member forces here? Remember, this is first year. Okay, so the first step is, okay, we want to know here the force connecting this joint, two member, not more than 2. Remember, not more than 2. Yeah, for the section, yeah, just now not more than 3. Maybe you confused. For the joint, not more than 2. For the section, not more than 3. For the resolution method, not more than 2. Yeah. For force resolution, we use the concept of joint equilibrium and also the concept of member equilibrium. Okay, the first step is joint equilibrium here. Okay, when you have 10 and 40 here, there must be another force. Yeah, another force. Yeah, to in opposite direction. Yeah, to this force. Okay. For this 40, you must another force here. And this 40 should be provided by this member force. No other member. This member cannot, because this member has no vertical component. Only one member. Okay, this side, only one member. So the direction of the arrowhead should be in opposite direction with the 40. Okay, check. Yeah, now check. Is there any other external force? No. Yeah, only 40. Okay, and then this is vertical. On horizontal, oh sorry, this one 10, it should be 10, not 31, 10. I cannot. This one 10. So you must have 10 here. Yeah, I go to, sorry, I don't know whether I can do it or not. This one 10. Okay. Successful. Oh, cannot. Oh. To repeat again. 30, 10. Okay. Okay. So now this joint now is in equilibrium. Yeah, in Y and also in X direction. Can you see that? Equilibrium. Okay, now we go to this member. Cannot. Now we go to this member. Okay. Now at this moment, can you see that this member is not in equilibrium? Here. This joint is in equilibrium already. Now this member, is it now in equilibrium or not? No. Yeah. So to make it equilibrium, to make it equilibrium, because the concept of equilibrium here, you learn in first year, you will use the concept of equilibrium of forces throughout the whole life of your career. Until we die, we use the equilibrium. Not only in structure, but in any, in all aspects of your life. Okay. So, to make it equilibrium, in y direction, we must put here 40. And this one 30, this one 30. This should be 30. Sorry, this should be 30. So now this member is in equilibrium. Can you see that this member is equilibrium? Okay. Summation of fx equals 0, 30 minus 30. Summation of fy equal to 0, 40, 40. So this member is in equilibrium. This joint is in equilibrium. Okay. So this is first resolution. What next? Okay. Sorry. Sorry, I have to repeat. I have to repeat this slide. Okay. I missed something here. Okay. You start with 14. Okay, this one. This is 30, not 10. I forgot this now. So, why it is 10? Why it is 30? It is 30 because when you combine 30 and 40, the resultant is collinear with this member. I repeat, the resultant of 40 and 30 is collinear with the member. Or, in other words, for the resultant of y and x is collinear with this member, this force should be 30. Why it is 30? Because ratio between horizontal and vertical dimension of this member is 3, 4. So if it is 4, it must be, if it is 40, it should be 30. I hope you can understand. I did mistake just now. 30 is correct. 30 is correct. Why 30? So that 30 is, we put 30 so that the resultant of 40 and 30, 50 is collinear direction, because it is impossible that the resultant is in direction. No, it should be in this direction because it is thrust member. A thrust member, it is axial load only. Okay. I hope you can understand. Then 30 and 40. You can check the resultant of this 30 and 40. It will be coincide or collinear with the member. And next, here. So what is the force here? Okay. Now you have 10 here. You have 30. So this joint, this joint now in horizontal is not equilibrium unless you put another here 20. Just now I said this joint is equilibrium. That one is in vertical direction, equilibrium 40, 40. But horizontally, it is not in equilibrium. Unless we put here one force. Since you have 30, that means you need another 20. 20 plus 10 equal to 30, but in opposite direction. Okay. So far understand? Okay, now look at this member. Is it equilibrium? This member? No. This member is not in equilibrium because you have 20. So to make it equilibrium, you put another force here. Okay. Now, next. Actually, it is enough. Yeah. But it is better. It is better for you to know what is actually the force in the member. For this member AC, the force is 20. What is the force in this member? If what is shown here is only rectangular component. What is the force? The force is equal to 50. Equal to 50. 30 squared plus 40 squared square root equal to 50. Okay. But normally in force resolution, we don't have to show 50. Just 30 and 40. 50 is when we need to summarize. Okay. So you understand? Okay. Now. This example, I think there is no solution. No solution. I hope you can use the concept here. Use the concept here to apply to this example. Okay. And then, if you have problem, I can show you the solution. Is it okay? Because I've shown to you the basic concept. Okay. So I just show you the check for stability and also the reaction. Okay. But for the force resolution or the member forces, it is maybe not included in your slide. But if you have problem, I can give the solution and I send through WhatsApp the solution. Okay. Based on this method or based on this guide principle, do you think that you can proceed with this one? Any answer? You try to proceed or what? Try. Yeah. Are you still there, or you have leave for lunch? Because I cannot see
Yes,
you. Yeah.
I'm still here.
Okay, you can try. You can try first. If you have problem, I give you until tomorrow. To do it yourself. If you have problem, then you message to me. Okay. Okay, we have another 10 minutes. We have one short topic here. Zero force member. There is no calculation. It is just a topic of observation. You can just observe and then you can decide whether a member is zero force or not. In many cases, we have to determine, we have to check what are the members with zero force. if we cannot decide or if we cannot recognize the zero force member, it will make you takes a very long time to solve the problem. That's why normally in exam or in test, one or two members will be made zero force. Any question? Okay. So even though the question does not mention you need to start with the zero force member, but you must do it to save time. Okay, so what is zero force member? Here, case 1. If only two members form a truss joint and no external load or support is applied, the members must be zero force member. There's no figure. I'll give you figure. And case 2, if three members from a truss joint for which two of the members are collinear, the third member will be a zero force member. Okay. I give you some example here. One example. If it is not enough, I'll give you another example in the next lecture. Here. Okay. What is the theory said? Actually, this is not a theory. This is observation. Actually. If a joint has only two non-collinear members and there is no external load or support reaction at that joint, then those two members are zero force member. For example, D and A. Okay, D and A. Only two members, meeting at the joint where there is no external load. Similar here. So both members are zero members. That means this member useless. Useless. Also this member. And if you do not know this principle or this observation or this notes, then it end up with you to spend time on calculating 1, 2, 3, 4 members. That's why before you start calculating the member forces, you must observe, is there any members have zero force? Similar here. In this example, also here, in this example, members DE, CD, AF, and AB are zero here. What's about this one? This one, this EC and BC, it is not zero member because you have force here. That's the difference. Or in another word, when you remove this one, two member, you remove two member, then this is the rest of the member. And you need to solve only 1, 2, 3, 4, 5, not 9. That's why the importance of understanding where which members having zero force. Okay. So there are many more cases. Okay. For this, sorry. If three members form a truss joint for which two of the members are collinear, the third member will be a zero force member. There is no figure here, but I can I can show you one example I noticed just now. Here. This example, not in this example, not in this question, but example of when there are two members meeting at a joint, no external force, but two of the members are collinear. two of the members are collinear, then the third member is zero force member. Okay, three member, yeah, meeting at a joint, yeah, but two member are collinear, so the third member will be automatically zero force. That is meant by the second principle of zero force member, case 2. Okay, yeah, I'll give you another example in the next lecture, yeah, for the zero force member. And the next lecture will be deformation of plane truss. And next week we'll start with the deflection of stress, bending stress, shear stress in a beam. Yeah, and the following weeks will be column, and then followed by torsion, and then if we have time, we can have maybe some type of tuition. I don't know whether it's practical or not. Tuition through online. We'll see later. How it can work. Okay. Any question, or maybe you prefer to write question through email or through WhatsApp? Any question here? Yeah, because we have to close this room. No question so far. Okay, I'll give you one maybe PDF tutorial. I'll give you tutorial for the plane truss. Maybe today. Okay, for each of your to the group. To the group. Okay. So, ada lagi ke tak ni? Senyap je. Ada semua. Okay. Terima kasih. Okay. Ada pun okay, saya pun suspend juga kalau semua dah tak ada ni. Okay, so terima kasih. Thank you. Thanks very much for your attention. And yes, as I mentioned before, I'll check another 4 students whether you are in or not. Amirul Aiman, are you here? Bin Rio Henry, tak ada. Faris bin Mat Razi, are you here? Okay. Nur Nadia Khadijah, also not here. Okay. Muhammad Afiq Hilmi bin Arsam. Siti Syakirah binti Muhammad Faizal.
Ada, Doktor.
Ada?
Ada.
Okay. Syukrina Fikriyah binti Muhammad Saga. Tak ada. And Taufik Hamdi bin Muhammad Azmi. Tak ada. Okay, so terima kasih.
Doktor. Afil ni ada tak?
Ada. Ada.
Dia ada dalam grup ni. Dia ada dalam participant.
Oh, ada. Tapi dia tak jawab. Dia tak tahu macam mana cara nak unmute kan. Saya pun tak bermain ni. Tak apalah, saya catat sini ada. Okay. So biasanya attendant macam mana? Macam tu ke ada cara lain attendant? Tak ada.
Biasa Dr. Yunus buat Google Form.
Google Form? Google Form you isi kemudian?
Setiap kali masuk Webex, dia akan bagi link isi Google Form.
Oh ya, nanti saya tanya dia lah. Tapi macam ni okey tak? Saya buat tadi dalam masa 5 minit lah tadi. Okey kot dalam masa kita rehat tadi, ya, take 5 tadi kita buat ni, selesai lah. Okay, so thanks again. Yeah, see you on Wednesday. Yeah, 11 o'clock. Okay, thank you. Bye bye. Yeah.
Terima kasih, Doktor.
Thank you, Doktor.
Yeah.
Thank you, Doktor.
Thank you, Doctor.
Thanks. Okay. Good day.